Okay. Geometric sequences. So, formula for geometric sequences is a sub n equals a sub 1 times the quantity of r to the n minus 1 power. I know there's a lot going on here, but we're going to do this in class too. Please remember this formula. This formula is key. Let's break down each individual part of this. A sub n is, which term do I want? What term am I looking for? A sub 1 is the first term. I think we remember that from the last thing we did with arithmetic sequences. I'll get into that in a minute. R is the common ratio, and n minus 1 is what term am I looking for? What's the term that I'm actually going to be multiplying by here? So, geometric sequences is different from arithmetic sequences. We did arithmetic sequences last unit. Arithmetic sequence has a common difference, which is adding or subtracting. The common difference is an adding or subtracting number. The geometric sequences is a common ratio. So I'm a multiplier at this point. I'm using a multiplier number. That's what the common ratio is going to be. So let's do a practice problem. A sub 1 is 3, so the first term is 3. The common ratio is 2. I'm looking for a sub 4. So let's put in what we know into the formula. So I'm looking for the first term, which is 3. The common ratio is 2. And n minus 1. So it's actually 4 minus 1. But it's not really 4 minus 1 because I'm just going to make 4 minus 1 a 3. Right? So this is how I find the fourth term in the sequence. You can put this in your calculator and it will work correctly, but I want to make sure that I'm using PEMDAS in my head first. So 2 is going to be raised to the third power, which is 8, and then I'm going to multiply it by 3, so that's 24. So let's work this through. If the first term is 3, right, okay, that would be the first term, so that'd be to the 0 power, 1 minus 1. Right? So 2 to the 0 power is 1, times 3 is 1. Let's find the second term, so 2 minus 1. Okay, so that's just going to be simply 1. So 2 to the first power is 2, times 3 is 6. Now I want the third term in sequence, so this is 3 minus 1. Okay, so it's 2. So 2 to the second power is 4. So 4 times 3 is 12. Now we are back to the fourth term, which is 4 minus 1, right? Which is just simply 3, which gives me 24. Okay, so you can see that what I'm doing here is I'm taking the previous term, multiplying it by 2. Common ratio is 2. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So if I were to do the next term, the fifth term in the sequence, fifth term. First term, second term, third term, fourth term, fifth term. A sub 1, A sub 2, A sub 3, A sub 4, A sub 5. Okay? So that's how we do these types of things out. Let's do one more, this method. Let's say I say A1 is negative 2. The common ratio is negative 3. And I want to find A sub 3. All right? So let's plug in what we know. First term goes first. Common ratio goes in the middle. And then this is really 3 minus 1 up top, so it's going to be simply 2. So I'm going to work this out. Negative 3 squared is 9. Right? And negative 2 times 9 is going to be negative 18. So the third term in the sequence is negative 18. Let's go the other way around. You don't have to do this other way. I just want to make sure you're understanding it. So the first term is negative 2. The second term then, right, so negative 2, times the quantity of negative 3 to the first power, which would be 6. Okay? And then the third term, which what we did, was negative 18. So the common ratio is negative 3. Negative 2 times negative 3 is 6. 6 times negative 3 is negative 18. Okay? So we're going to work a lot with this in class. I want to just do these two problems because you're going to see this a whole bunch of different ways. Okay, so that first way is what we'll start with today on Monday. Otherwise, you're going to do it like this. Here, first we have to determine if the sequence is geometric. And you're going to know that because there's a common ratio. Then I want to find the common ratio. See, in these two problems, I need to find what R is. I'm not giving you R. It's not going to be that challenging. And then I want the eighth term. Okay, so I will need a calculator for this, most likely. All right, so very simple. What did I have to multiply 1 by to get to 6? And it's always going to be the same. So the common ratio, that's why we call it common, because it will always continue. So 1 times 6 is 6. 6 times 6 is 36. 36 times 6 is 216. So the first term is 1. My common ratio is 6. And I'm looking for the n minus 1 power. But again, I'm looking for the eighth term. So this is essentially 8 minus 1, right? Which is just 7. So this is my formula. So 6 to the 7th power, and yes, these numbers are going to be very big, times 1. So that's 279936. My answer is 279,936. You're going to have bigger numbers. Don't worry about it. That's my answer. All right, good. And yes, it's geometric. Don't worry about explicit formula. We just did the explicit formula. This is the explicit formula. This is the explicit formula. Okay. Here, let's do another one. What did I have to multiply 3 by to get to 18? Now, there's an easier way to do this, but I want to go this way first. 3 times 6 is 18. 18 times 6 is 108. So 6 is going to be the common ratio again. First term is 3. Common ratio is 6 to the n minus 1 power. Well, I want the 8th term. So again, this is going to be to the 7th power. Okay, so 6 to the 7th power. It's going to just be a little bit different. The same number we just had, times 3. My answer is very big. It's 839,808. Now, let's just confirm our work to make sure that we didn't make a boo-boo. Boo-boo. Okay. Answers are right. Explicit formula we just did, right? So it's just what we did just here. Okay. Now, what happens if, I don't know, 6 isn't the common ratio? What happens if you don't know what the common ratio is? You know, like what happens if it's fractions and you're like, oh my God, I'm going to guess forever to find it. No, not necessarily. The easiest way to find the common ratio is take the second term in the sequence, so 6, divide it by the first term or the term previous to it. That's your common ratio. Okay? And you can take any of these. So for instance, let's take the 4th term in the sequence. Divide it by the previous term. So 216 divided by 36, that's 6. If you get this, and it's the same, it is a geometric sequence, and that's the common ratio. Like for instance here, what if I didn't know 3 was the answer, the first term here? I'm going to take the term, the second term that's in line, or the third term, divide it by the previous term. So 108 divided by 18, and I'm going to get 6 here, right? So then I would know that 6 is my common ratio. Let's go again. I'll take the 4th term and divide it by the previous term, just in case I had no clue. 648 divided by 108. That is also 6. Because they match, because the common ratios match, I know it's a geometric sequence, and I know that's my common ratio. All right? We're going to work this out a lot. It's going to be weird at first, but you're going to get the hang of it very quickly. All right?